In this session, we're going to talk about the anatomy of a Spark job. We're going to look at how clusters are typically organized that Spark runs on. And this is actually important. It's going to come back to the programming model once again. You can't just pretend like you have sequential collections that are on one machine. You actually have to think about how your program might be spread out along the cluster. So let's start with a simple example to try and motivate this. Let's say we have a case class person. It's got a name, which is of type string, and an age, which is type int, okay? And let's say we have an RDD full of these person objects. So we have an RDD called people. Now, if we say people.forEach and we print line, so we just want to print out all of the people in our RDD, what happens? I'm going to give you a minute to think about it, or maybe even to look back at your previous notes. Actually, before answering that question, let's look at a second example. Assuming, again, we have an RDD full of these person objects, and I say people take 10, what happens? Where will the array of person objects that is returned by take 10 end up? I'll let you think about this too. Before I give you the answer for both examples, let's first look at how Spark jobs are executed. Spark is organized in a master-worker topology. Remember, you are writing a program which is then getting distributed to a bunch of workers where your data is, and typically roughly the same operation is being done across all of the workers. So usually there's one master and many workers. In the context of a Spark program, we refer to the node that acts as the master as the driver program, and we refer to the workers as the worker nodes. Now, the driver program is where this Spark context is. So this is the thing that we are using to create new RDDs, to populate new RDDs. So when we do Spark context or sc.parallelize or sc.textfile, we're actually using this thing here in the driver program. When you write a Spark program, you write a Spark program from the perspective of this node here. So you think as if you are the driver node and you're giving commands to worker nodes. So this is the node that you're interacting with when you're writing Spark programs, and these are the nodes that are actually doing the jobs. So the executors are actually doing all the work, and this is coordinating the work. You can think of it that way. But of course, how do they communicate? They communicate via something in the middle called a cluster manager. And a cluster manager is what actually does the work of doing all of the scheduling and managing resources across the cluster. It keeps track of everything. It does a lot of bookkeeping. Popular cluster managers are Yarn or Mesos. So often when you're running on a real big cluster that you're maintaining yourself, you typically choose one of these cluster managers to run on top of. Okay, so this is more or less the anatomy of a Spark job. So you have this driver program, you have your Spark context in it. All of it is kind of passing through this cluster manager thing that takes care of stuff like memory and whatnot. And all of the work is being done in these things called executors on the worker nodes. So when you take a step back, it's best to think of a Spark application as a set of processes that are running on a cluster where the driver program, the driver node here, the master node, is coordinating all of these processes. And it's important to remember that the driver is where the main method of your program runs, and the process running the code that creates the Spark context, it creates RDDs, and it stages up and sends off transformations and actions, that all lives here on this driver node. So the driver node, or the driver program, is really the brains of your Spark job. So these processes that make up a Spark application, these are all running in these executor things here, and this is also where your data is stored and cached. So just to summarize, executors run the tasks that represent the application. They return the computed results to the driver. So whenever an action is done on one of these executors, the executor is the one that returns the result back to the driver program.